Today we're going to talk about the pipeline skybox, which includes RSTRENG. And the first thing, you should have received your username and password. So let's log in. As you can see, we have multiple engineering tools, and these are the network power tool, the pipeline toolbox as we know it, also a fluid, equipment, RSTRENG, AC mitigation, and of course the pipeline corrosion power tool. Well, before we get started, one of the things we must do under preferences is select whether we're going to be RSTRENG US or RSTRENG metric. In this case, I'm going to select RSTRENG US. We're going to hit OK. And we're going to get a screen change, as you can see. Once that screen change occurs, we could move over to RSTRENG. So what do we do? How do we get started? Well, it's very similar to the old RSTRENG program, RSTRENG 5. Okay, but we have new features in this program. And some of the features that I would like to talk about is we have better graphics. We have the capability to zero out long length corrosion to determine where to put our composite sleeves. We have unlimited number of increments that could be added into the system. We have the ability to be meeting the traceable, verifiable, and complete with PHMSA TVC capabilities. And we added 3 more software, or 3 more calculations, the DNV, the API 579 level 1, and PCOR. There was requests for these, but and we feel that this is going to enhance the program immensely. So what do we do? How do we get started? Okay. As you know, you probably may have had data in the program. We could bring in data. We could select data. And this is one of the nice things about getting information very quickly. Let's just give a case of how the program works, and then we'll get into creating a file. If you had previous data in this program, this is all it takes, is to bring it up, hit calculate, and you're ready to go. It's that simple. One of the features that we've done with this program, it's going to give you the first effective area. This is RSTRENG. As I go down, we have the 50 modified criterion, and you notice this pressure is generally less. Why is RSTRENG showing a higher maximum safe pressure? Because it's a level 2 calculation. All of the other ones, 850 modified, the ASME B31G, the DNV calculation, the API 579, and the PCOR are all level 1. What does that mean? Level 1 only takes the maximum length from here to down here. This happens to be about 115 inches, and the maximum depth, which happens to be 184 mils. You notice when I moused over there, it gave us the distance, 96, and the depth. And also this one is 12 inches and 184. So it picks the 2 worst cases, or if there's one. And this is what one of the benefits of the program. We also have a repair line. This is created by DOT or PHMSA. Anything greater than 80%, you must repair. We also have a capability to determine where to make the repairs. And this is called the zero out method, and I'll get into that in a little bit. So let's talk about records. We could open this. This is another way to do it. We could open records. This is a different way to do it. I showed you the first way up here. We could come in this way and look at all the records. Now all of a sudden we're beginning to see all the information about the file that we're looking at. The case name. Let's select the one we're at. 14.1. Okay. It's called 14.1. Who performed the inspection? The line ID. The location. This happened to be at our office, level 7. That's our milepost. The geographic information. Lat long. Your outside diameter, 24-inch. Wall thickness. Oh, you can change it in millimeters, centimeters, or back to inches. You could also default it the way you want it, if you want it in metric, as I showed you earlier on the preferences. We also have a specified minimum yield strength, PSI. And for the purposes of the DNV calculation, we need to put the ultimate tensile strength in there, and that's 66,000. We have a reference document on that and how to get the number on that. In this case, this is a gas line, and it's in a Class 2 area because it has a 0.6 design factor. This is the modified criterion. This is the most famous formula that we got started from, and this is called the design formula, Barlow's formula. It started at, and it calculates the pipe that could operate at 811.2 pounds. The client or the gas company elected to operate at 811, and we have up to 850 characters we could put in comments now. We could update it, we could load it. In this case, we already loaded it, but let's load it again. Okay? And here it is. What about our data? Where does our data come from? We could import an Excel file. We could export an Excel file. Okay. What do you want to do with the pit depth? I want to save it. I want to open it. And this is the way we would bring in our data. So I just want to show you how easy it is. So you already have a format of how to bring your data in. Pipe increment. They don't have to be. They could be any increment. It could be tenths of an inch. They could be in metric system, in millimeters. The pit depth is in mils. You could put it in inches if you wanted to. You select the way you want to bring it in. In this case, this is in inches and in mils. And we have approximately 115 inches of corrosion. We generally start with a 0, or we don't have to start with a 0, but we need to end in a 0 in order to have the program work. I'm going to enable editing. I'm going to save this file, and I'm going to put it in a RSTRENG folder, and we'll call it pit depth 26. We'll save it. I'll bring it back later. Okay. Are we done? Guess what? We're almost done. That's how easy it is. So let's start as if we're starting from fresh. So let's get in here. We're going to do new. We're going to do a new site. So what do? Let's hit new site. Let's create a case name of ABC. We're going to call it a line, we'll make something up, main line A. And we'll say that the location is in Kirby Drive. And it happens to be in room 710. And the geographic information is east 1, 2, 3, 4, 5, 6, 7, 8. Pipe diameter is let's make it a 30-inch. Make it 375 wall. Smythe value of 52,000. The UTS value is 66,000. And I'll show you where you get that in a minute. We're going to call it a design factor of 0.72. So at 0.72, you notice these calculated. And we're going to operate at 900 pounds. And we could put whatever amount of comments we want in there. Okay. We're going to update and save profile. We're going to load the profile. And now we need to bring some data in. Let's import some file. Let's select a file. So I'm going to go into my RSTRENG. I just selected the file. It's in inches and mils. You could select them. Let's import. Let's hit OK. And whenever you see the green calculate button move it up, let's calculate it. And voila, we are done. Well, everything's red. We're in trouble, aren't we? And there's all degrees of red, from 793, 524, every known value you could think of. Why do we have so many different maximum safe pressures? Well, they all calculate different. They all look at a different way of calculating. Let's go to the next step. What do we need to do? How many composite sleeves do we need? Let's zero it out. So the first one we're going to do we'll calculate. And you notice that the pressure's changed. This is at 801. And what is our established MALP? 900. Well, we've got a ways to go yet. We've got more repairs. What 01 does is bring it to its original full wall thickness. So we're going to zero it out again. And guess what? We get a new calculation. So if we put 2 composite sleeves on, we have just improved the integrity of the pipe. Well, it just turns out we're still not at 900 pounds. Otherwise, we have to reduce pressure. So we're going to zero it out again. We'll calculate. And guess what? We are now above the established MALP. In fact, we're back to the original design, 936. Okay? What we could do is create a report. So we hit create a report. Save, open. And here is what we just accomplished. We brought everything back up. This is the information with the repairs in place. And it looks like the only two that still failed was B31G and A21 and 579. Extremely conservative. If you look over here at the safety factors, a 0.72 design means you have to get above 1.39. If you take the reciprocal of 0.72, that's 1.39. And anything above 1.39 coincides with the safe pressure. And here's all the information. You know, where these composite sleeves need to go, where we zeroed out. What have we just done? We've just saved the client or the company a great deal of money, particularly if you have long length corrosion. So now you're able to make these repairs as well as save the company money. What's next? Well, let's go back to the way it was. Okay, and we're going to calculate. Oh, what did I forget to do, folks? I forgot to save it, didn't I? This is an important lesson. I did that deliberately. Okay. Got the data back. Let's save it as ABC. I saved the data input, but I didn't save the profile, did I? Let's calculate. Let's run it again. Okay. Let's produce a report. And here's the zero out method if you wanted to see everything. If you noticed, we could have just produced this report and we would have known that these are the three areas that needed to be fixed. They happen to be 9 inches, 9 inches, and 8 inches long. So what we've done, we're able to help the client save a lot of money, particularly when you put clock springs on or other composite materials, which are usually about $15,000 about per foot. That's just for the materials. So just wanted to show where the cost savings come in. We could export this to a spreadsheet, and you could take it from there and produce a report from it. Where do we put our inspector data? Well, this is where we put it in. And we're going to update. Producing the report is the same thing. We could create a report again with all the information. We could save it, open it, and we'd have the same information. So we could have it as is, and then with it as mitigated or repaired with a composite sleeve or sleeve. RSTRENG is one of the few tools that is approved by the regulators. In fact, it's even written in regulations 192 and 195. Running these calculations are fairly easy. Producing reports are very easy, as you could see. And in the end, anytime there's support, Technical Toolbox is here to assist you. If there are any questions, please call Joe Pikus. Thank you.